Welcome back to the channel. In today's lesson, we're diving into one of the most powerful tools in Python, lists. Whether you're brand new to coding or brushing up your skills, lists are essential for organizing and working with data. We'll cover how to create them, access items, modify values, and even sort and join lists, all step by step. By the end of this video, you'll be confident using lists to build smarter, more dynamic Python programs. So grab your editor, follow along, and let's get started. Okay, we're over in the text editor now. As you can see, I've got a file open called lists.py. You're welcome to follow along as we go. This exact file is available to download from the website, just check the link in the description below. Let's walk through it together, step by step. Alright, first up, let's talk about what a list actually is in Python. A list is like a container that holds multiple items in a specific order. You can store anything in a list, words, numbers, or even a mix of both. In this first example, we've got two lists. The first one, fruits, holds 3 strings, each one is a piece of fruit. The second list, mixed, shows that you can combine different types of data, a number, a string, and a decimal. When we run this code, Python prints both lists to the screen. Now, if you're following along in your editor, you might want to temporarily turn lines on or off like I am doing. Here's a quick tip. To comment or uncomment a line, just click anywhere on it and press Ctrl+/ on Windows or Command+/ on Mac. This shortcut adds or removes the hash symbol at the start of the line, which tells Python to ignore it when running the code. Try it out like me to see how it works. Now, if we run this file in the terminal, we'll see both lists printed out. The first output will show the fruits list, apple, banana, cherry. The second output will show the mixed list, 42, hello, 3.14. This confirms that Python can store different types of data in a list, like strings, numbers, and decimals, all in one place. Next up, let's look at how to access individual items inside a list. Let's break it down. Fruits, 0, grabs the first item in the list. In Python, counting starts at 0, so this prints apple. Fruits, -1, uses negative indexing to grab the last item in the list, which is cherry. Len, fruits, tells us how many items are in the list. In this case, it returns 3. Now, let's run this in the terminal. This shows that Python can access list items from the front and the back, and it can count how many items are inside. If you want to experiment, try changing the index numbers or adding more items to the list and rerunning the file. Alright, if your terminal is starting to look a bit cluttered, here's how to clear it. Just look for the 3 little dots in the top right corner of the terminal window. Click on those, and from the drop-down menu, select Clear or Clear Terminal. This wipes the screen clean, but don't worry, it doesn't delete your code or stop your program. It just gives you a fresh view so it's easier to focus on the next output. You can do this anytime things get messy or you want to reset the view before running your code again. Now let's see how we can use a single item from a list inside a sentence. Take a look at this line of code. Here's what's happening. Fruits, 1, grabs the second item in the list. Remember, Python starts counting at 0, so index 1 gives us banana. The F before the string means it's a formatted string. It lets us insert values directly into the sentence using curly braces. So this line builds the message, I love banana, and stores it in the variable called message. Then print, message, displays that full sentence on the screen. This is a great way to combine list values with custom messages, perfect for dynamic output in your programs. Now let's look at how to change an item in a list. This line updates the second item in the fruits list. Remember, Python starts counting at 0, so index 1 points to banana. We're replacing banana with blueberry. Then print, fruits, shows the updated list in the terminal. This is how you modify a list. Just point to the item by its index and assign a new value. Try changing other items in your list and rerun the file to see the results. Now let's talk about how to add new items to a list. In this example, we're using 2 different methods. First, we use fruits. Append, date. This adds the word date to the very end of the list. It's a quick way to grow your list one item at a time. Next, we use fruits. Insert 1 kiwi. This adds kiwi at position 1, which places it between the first and second items. So instead of just adding to the end, we're inserting it exactly where we want. Now let's go over how to remove items from a list in Python. There are a few different ways to do this, and each one works slightly differently. First, we use del fruits 0. This deletes the item at index 0, which means the very first item in the list is removed completely and permanently. Next, we use last underscore item equals fruits.pop. This removes the last item from the list and stores it in a variable called last underscore item. That way, we can still use or display the item later if we want to. Then we use middle underscore item equals fruits.pop 1. This removes the item at index 1, so the second item in the list, and stores it in a variable called middle underscore item. After that, we use fruits. Remove cherry. This looks for the first item in the list that matches the value cherry and deletes it. Finally, we print out the results. Print last underscore item shows the item we popped from the end. Print middle underscore item shows the item we removed from the middle. And print fruits shows what's left in the list after all the changes. This section is a great example of how flexible Python is when it comes to removing items, whether by position, by value, or by saving them for later use. Now let's look at how to organize a list in Python. This means sorting the items or changing their order. First, we use print sorted fruits. This shows the list sorted in alphabetical order, but it doesn't change the original list. It's a temporary sort, just for display. Right after that, we print fruits again to show that the original list is still unchanged. Next, we use fruits sort. This sorts the list permanently, updating the order inside the list itself. When we print fruits again, we'll see the items now appear in alphabetical order. Finally, we use fruits reverse. This flips the order of the list, so the last item becomes first, and the first becomes last. Each of these methods helps you organize your data depending on what your program needs. Try running this section in the terminal to see how the list changes after each step. Now let's find out how many items are in our list. To do that, we use the len function. In this example, we write print len fruits. This tells Python to count how many items are currently inside the fruits list and then print that number to the screen. So if the list contains 5 items, the output will be 5. This is a quick and reliable way to check the size of any list, especially when you're adding or removing items and want to keep track of how many are left. Now let's talk about how to avoid index errors when working with lists. In Python, every item in a list has a position called an index. If you try to access an index that doesn't exist, Python will show an error called an index error. To prevent this, we can check the length of the list before accessing a specific item. In this example, we use the line, if len fruits greater than 2. This checks whether the list has more than 2 items. If that's true, then Python runs the next line, print fruits list item 2. This safely prints the third item in the list, without risking an error. Using this kind of check helps your program run smoothly, especially when the list might change in size. Now let's learn how to loop through a list in Python. When we want to do something with every item in a list, we can use a for loop. In this example, we write for fruit in fruits. This line means, for each item in the fruits list, temporarily call it fruit, and then do something with it. On the next line, we write print fruit, which tells Python to print each item one by one. So if the list contains 5 fruits, this loop will print all 5, each on its own line. This is a really useful way to work with lists, especially when you want to repeat an action for every item. You can also replace print fruit with any other code to do something more interesting with each item in the list. Now let's learn about something called list comprehension in Python. List comprehension is a quick way to create a new list by applying a rule to each item in a sequence. In this example, we write squares equals x to the power of 2 for x in range of 5. This line creates a list of square numbers. It takes each number from 0 to 4, squares it, and adds it to the list. So the final list will be 0, 1, 4, 9, 16. Then we use print squares to display the result. List comprehension is a powerful tool that lets you build lists in a clean and readable way. It's especially useful when you want to transform data or apply a formula to every item in a range. Now let's learn how to make a copy of a list in Python. Sometimes we want to duplicate a list so we can work with the new version without changing the original. To do that, we use the copy method. In this example, we write new_list equals fruits, copy. This creates a brand new list called new_list, which contains the same items as the original fruits list. Then we use print new_list to display the copied list on the screen. This is useful when you want to experiment with a list or pass it to another part of your program, but still keep the original list unchanged. We can also join two lists together in Python. Sometimes we want to combine an existing list with new items to make one larger list. To do that, we can use the plus sign between two lists. In this example, we write combined equals fruits plus grape, melon. This creates a new list called combined, which includes everything from the original fruits list, plus the new items, grape and melon. Then we use print combined to display the full list. This is a simple and effective way to join lists and build new collections of data. Let's take a moment to talk about numbers in lists. Just like strings or other types of data, numbers can be stored, accessed, and modified inside a list. You can use them for calculations, sorting, or looping through values. Python makes it easy to work with numbers, especially when you want to generate a sequence. One way to do that is with the range function. Let's look at two quick examples. In the first example, we write for number in range 1, 5, print number. This loop starts at 1 and goes up to, but does not include 5. So it prints the numbers 1, 2, 3, and 4, each on its own line. The number 5 is skipped because range always stops one number before the end. In the second example, we write for number in range 1, 6, print number. This time, the loop includes the number 5 because we set the end value to 6. So it prints 1, 2, 3, 4, and 5. Using range is a simple and powerful way to control how many times a loop runs and what numbers it uses. You can adjust the starting and ending values to fit your needs, and even add a step value if you want to skip numbers or count by 2s, 3s, or more. Here is how to create a list of numbers using the range function. In this example, we write numbers equals list, range 1, 6. This line tells Python to generate numbers starting at 1 and ending just before 6. Then it wraps that range in the list function, which turns the sequence into a full list. So the result is a list that contains 1, 2, 3, 4, and 5. Next, we use print numbers to display the list on the screen. This is a quick and powerful way to create a list of numbers without typing them out one by one. You can change the starting and ending values to create any range you need. Let's create a list of numbers that follow a pattern, like even numbers. We do this using the range function with 3 values, a start, a stop, and a step. In this example, we write evens equals list, range 2, 11, 2. Let's break it down. The first number, 2, is the starting value. That's where the list begins. The second number, 11, is the stop value. Python will go up to, but not include, this number. The third number, 2, is the step value. It tells Python to count by 2s. So this line creates a list of even numbers starting at 2 and ending just before 11. The result is 2, 4, 6, 8, and 10. Then we use print evens to display the list on the screen. This is a great way to build lists with custom spacing, like counting by 2s, 3s, or even 10s. Just change the step value to control how the numbers are spaced. As you can see, we can also create a list of odd numbers using the range function. In this example, we write odds equals list, range 1, 10, 2. Let's break it down. The first number, 1, is the starting value. That's where the list begins. The second number, 10, is the stop value. Python will go up to, but not include, this number. The third number, 2, is the step value. It tells Python to count by 2s. So this line creates a list of odd numbers starting at 1 and ending just before 10. The result is 1, 3, 5, 7, and 9. Then we use print odds to display the list on the screen. This technique works for any pattern of numbers. Just adjust the start, stop, and step values to fit your needs. Now let's say we want to build a list of square numbers, but do it step by step. Instead of using list comprehension, we can use a loop and the append method. Here's how it works. We start by creating an empty list called squares. Then we write a for loop. For number in range 1, 11, this loop goes through the numbers from 1 to 10. Inside the loop, we calculate the square of each number using number asterisk asterisk 2. We store that result in a variable called square. Then we add that square to the list using squares. Append square. After the loop finishes, we use print squares to display the full list. The result is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. This method is helpful when you want to build a list gradually, especially if you need to add extra logic or conditions along the way. There's another way we can build a list of square numbers, and it's much shorter. Instead of using a loop and the append method, we can use something called list comprehension. In this example, we write squares equals number asterisk asterisk 2 for number in range 1, 11. Let's break it down. This line tells Python to go through the numbers from 1 to 10. For each number, it calculates the square using number asterisk 2. Then it adds that result directly into the list. The entire list is built in one line, and the result is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Finally, we use print squares to display the list on the screen. List comprehension is a clean and powerful way to build lists quickly, especially when the logic is simple and consistent. Here's how we can get some simple statistics from a list using Python. Let's say we have a list of digits that looks like this. Digits equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. To find the smallest number in the list, we use the min function, print min digits. This prints 0, which is the lowest value in the list. To find the largest number, we use the max function, print max digits. This prints 9, which is the highest value in the list. To find the total of all the numbers combined, we use the sum function, print sum digits. This prints 45, which is the sum of all the digits. These built-in functions make it easy to get quick insights from your data, and they work with any list of numbers. Now let's move on to slicing lists in Python. Slicing means taking a portion of a list, rather than the whole thing. It's a great way to grab just the part you need. In this example, we write players equals Charles's, Martina, Michael, Florence, Eli. Then we use print players 0 to 3. This tells Python to start at index 0 and stop just before index 3. So it prints the first three names, Charles, Martina, and Michael. Remember, Python starts counting at 0, and the slice always stops one item before the end value. You can use slicing to pull out any section of a list, whether it's the beginning, the middle, or the end. We can also loop through just part of a list using slicing. This is helpful when you only want to work with a specific section of the list, not the whole thing. In this example, we write for player in players 3, print player. As you can see, because we commented out the players list, Python has thrown us a name error. It's telling us that players is not defined, because the list doesn't exist in the current code. From this, we can work out that we need to uncomment the players list so Python knows what we're referring to. Once we fix that and run the code again, the print call inside the loop will work properly. It will loop through the first three names in the list and print each one. Working with Python means getting comfortable with errors and debugging. It's a normal part of the learning process. Errors are not failures, they're clues. They help us understand what the code is doing and where it needs fixing. The more you practice, the better you'll get at spotting and solving these issues quickly. This loop goes through the first three items in the players list. The slice players 3 starts at index 0 and stops just before index 3. So it prints Charles, Martina, and Michael, each on its own line. Looping through a slice is a great way to focus on a subset of data, like the top 3 scores, the first few names, or the latest items in a list. You can adjust the slice to target any section you need. Let's look at how to copy a list in Python. There are 2 simple ways to do this. First, we use slicing. Copy 1 equals players with a colon in square brackets. This tells Python to take everything from the beginning to the end of the list. The colon means start at the first item and go all the way through. If we had a number before and after the colon, this would tell Python where to start and end the slice. So copy 1 becomes a full copy of the original players list. Second, we use the built-in.copy method. Copy 2 equals players.copy. This does the same thing. It creates a new list with the same items. When we print both copies, both copy 1 and copy 2 will show the same list of names. Copying a list is useful when you want to make changes to one version without affecting the original. And slicing gives you even more control if you want to copy just part of the list. Before we wrap up this video, let's take a moment to talk about tuples in Python. Tuples are similar to lists. They hold a collection of items. But unlike lists, tuples are immutable, which means you can't change their contents once they're created. We define a tuple using round brackets, like this: dimensions equals 1920, 1080. This tuple stores 2 values, in this case the width and height of a screen. To access an item in a tuple, we use indexing, just like with lists. So when we can write, print, dimensions with 0 in square brackets. Python then prints 1920, which is the first item in the tuple. Tuples are useful when you want to store a fixed set of values that shouldn't be changed, like screen sizes, coordinates, or settings. They're simple, fast, and easy to use. We can also loop through a tuple, just like we do with a list. Even though tuples can't be changed, we can still access each item one at a time. Here's how we do it. We write a for loop that goes through the tuple. For example, for dimension in dimensions, print dimension. This loop prints each value in the tuple, first 1920, then 1080. Each number appears on its own line. Tuples are great for storing fixed sets of values, and looping through them is just as easy as looping through a list. Although we can't change the individual values inside a tuple, we can reassign the entire tuple. This means we're not editing the original tuple, we're simply replacing it with a brand new one. For example, let's say the originally has 1920 and 1080. Later on, we decide to update those values. We can do that by assigning a new tuple to the same variable name. Dimensions is now equal to 1280, 720. Now, when we print the tuple, Python will display the new values, 1280 and 720. So even though tuples themselves are immutable, the variable that holds them can be updated to point to a different tuple. This is a common pattern when you want to keep your data fixed, but still allow for occasional updates by replacing the whole set. It's a clean and safe way to manage values that shouldn't change often, like screen sizes, default settings, or fixed coordinates. That should cover the basics for now. If you found this helpful, don't forget to like and subscribe. It really helps support the channel. You can download the cheat sheet from the description below, and there's also a link to the list section of the website if you'd like to dive deeper. Thanks for watching, and keep practicing. Python gets easier the more you play with it. Until next time, happy coding.